Hello, my name is James Finch. I'm a PhD student advised by Jinho Choi at Emory University's NLP lab. And today I'm going to be presenting our new dialogue development framework, Emora STDM. So anyone who has worked on developing a dialogue system knows that it's a ton of work. Of course, in research, we like to focus on trying to train conversation models from data, but often the reality is that you have certain specifications for your system that just aren't represented well by any data set. So in these cases, handcrafting, or at least defining certain constraints for your system's behavior, is inevitable. The purpose of dialogue development frameworks is to streamline the process of creating a dialogue agent, especially when handcrafting starts to get involved. So a lot of frameworks are already out there, but we believe none balance ease of use with customizability quite as well as what I'll present today. So for example, there's a lot of commercially oriented frameworks like Google Dialogflow. These are really easy to use, but they do sacrifice customizability. The academic community has also produced a class of frameworks that are driven by update rules that follow the information state theory of dialogue management. So these support complex interactions, but they can be cumbersome when you're just creating a simple system or doing rapid prototyping. Finally, there are some frameworks that are actually languages, like AIML or ChatScript, but these tend to focus on modeling user initiative conversations with pattern matching, which is just inherently limited. So we present Emora State Transition Dialog Manager, or Emora STDM, which is a Python package and framework for dialogue system development. Our goal is to maximize speed and intuitiveness without sacrificing any customizability for expert developers or researchers. And Emora STDM achieves this by seamlessly integrating pattern matching, trained models, and custom logic. It also supports two fully interoperable dialogue management approaches. One is based on state machines for rapid development, and the other is based on information state theory for modeling complex interactions. So getting a dialogue agent up and running in Emora STDM can be done very quickly, just by defining a state machine to drive dialogue management. The dialogue context is efficiently modeled as a state in the state machine, and transitions alternate between representing user intents and then system responses. Defining the structure in the state machine using code is done with a very easy to use JSON syntax. And this syntax reflects the hierarchical nature of conversation pretty elegantly. Now, distinguishing which transition to take during the user turn especially is done using our novel natural language understanding mechanism, which we call the natural language expression, or Natex. So Natex is an extension of regular expression it has a custom syntax specifically geared towards pattern matching for natural language. It functions by compiling into a regular expression, so it supports all the features of standard regex, but unlike standard regex, Natex allows developers to embed function calls to arbitrary logic within their pattern matching expressions. So this allows seamless integration of quick-to-develop pattern matching with database queries, trained neural models, or any other custom logic that you might need. So for an example, consider this Natex, which attempts to capture the user expressing that they like a certain activity. And the $ notation there is representing that it's also trying to save whatever activity was matched into a variable called X. So we would like, what we would like to happen is for the third term of this pattern matching expression to basically run a part of speech tagging model and match any token from the user input that's a verb. So when the user is when the Natex is matched against a user input string, the function call term will call a custom function during the compilation of the Natex into a regular expression. So these Natex functions are easy to define, such as this one that finds all the verbs in the user input using a part of speech tagger. This function returns a set of matching tokens, which are then embedded back into the Natex to continue pattern matching. So this formulation allows simple pattern matching to be easily extended by powerful logic whenever you need it. An additional feature of our Natex formulation is that it can be used for natural language generation as well. So a Natex can generate variant system responses by essentially randomly selecting an element from each disjunction clause. This allows developers to easily create variety in system responses, as well as taking advantage of Natex's ability to set variables or call custom functions for even more sophisticated generation. So by defining a state machine where each transition is modeled using a Natex, a high volume of simple interactions are easy to develop and then extend to be more complex. Since any variables set by a Natex during a transition persist throughout the conversation, interactions can be parameterized, and they can also recall previously learned information, which can give the user a true feeling of understanding. Okay, so while great for rapid development, using a state machine alone for modeling dialogue is notoriously rigid. And so for this reason, Emora STDM additionally supports a dialogue management mechanism based on information state theory, where a set of update rules is allowed to arbitrarily modify the dialogue state and response. So each update rule is formulated as a conditional if-then statement, where the precondition is a Natex that is matched against the user input on a specific turn. And the postcondition is a Natex that running under the NLG compiler. Each turn before the state machine is updated, all update rules that can apply are triggered, which essentially allows more complex reasoning and conceptual abstraction of the user input. So as an example, suppose that the user mentions their wife during a conversation, and what we want our system to be able to do is reason that the user is an adult if they ever mention a spouse. So an update rule pattern matching for the expression my wife or my husband could be triggered. And then the post condition could set a flag indicating the user's marital status. Now, more than one update rule can trigger on any given turn. So once the marital status variable is set, this could in turn trigger a second update rule, which infers that if a user is married, then they're an adult. We could even want our system to directly output a response based on this information using an update rule. So for this example, we have a third rule checking if the user is an adult. And then this rule's post condition contains a natural language response for the system, as well as a priority score. So when an update rule post condition contains a priority score like this, it indicates that the natural language generated by the post condition is a candidate for the final system response. In this way, candidate system responses are collected both from the update rules as well as from the state machine system transitions. The candidate response with the highest priority is selected as the true system output. And by default, just all priority scores are 1. So in this case, the priority is 2, and so it would likely be the true response. In general, interactions based on update rules are more complex and they might require more expertise, but they allow for abstract reasoning and globally applicable responses and transitions. As a whole, the state machine and update rule mechanisms in Emora STDM complement each other. So of course you could develop an entire dialogue system just using one mechanism, but they each have different strengths. So defining transitions in the state machine can be done very quickly to build a foundation for the system's primary interactions, but then it can be supplemented by update rules to reason about learned information. At Emory NLP, our team certainly found Emora STDM to alleviate a lot of headaches that are typical when developing a large-scale dialogue agent, and we hope others can benefit from its public release. Thank you for watching.